Yes. Hello, Aaron. How are you?
Hello.
How things are going?
Oh, pretty good. How about you?
Yeah, I'm not complaining. So Levi was able to motivate you to do some help on the metal organic complexes.
Yeah, I guess he just asked for absorption spectra, and the models were small enough, so it wasn't a lot of labor to do what he was asking
Thank you.
for.
Thank you for doing this. I think he has more ambition and wants help with non-adiabatic dynamics and couplings. And he was refusing to do it himself. So he tries someone to help. Yeah, if you find it possible, it's valuable help for report on a grant. Hello, hello, you. Nice.
Hello, hello everyone.
Hello.
So I think Mead will join soon, and I'll do. Well, thank you for connecting, for sending your drafts of manuscript, and again, this year we are not going in the way how it should be. It's really, I really appreciate that everyone agrees on this unusual arrangement, writing a paper without a conference, which is not as it should be. It should be presentation on a conference first and writing of paper second. So some of you have sent the separate discussion section. Some of you sent like both, and some sent mix. So I'm going to just show briefly the little document that I did send you before, and I think for Aaron and Jeroen, you have seen this document or its versions many times, so it will be slightly new for Amir and Mead if he connects. So just in case we here in the meeting or anyone who watches the recordings of this meeting in the future is interested in our procedure. So if the discussion section and the whole paper is arranged after the conference, typically it is a very right place to put the objections of visitors to your poster or people who are asking questions by raising hand during the oral presentation. So it's a specifically designated place to repeat their question and your answer, or foresee possible questions and place answers on them to refute future criticism from reviewers. Also, if I doubt in the methods that I used, or if I anticipate that some of the reviewers may doubt this method, one can give some comments like what is the origin of the doubts and what is the origin to refute these doubts, why the method is most precise or most optimal, like and beneficial for given method. At least one can always say that there is a qualitative analysis of mechanisms rather than quantitative agreement. If there are part of results that didn't fit into straight logical following of the figures and tables, one can play this leftovers into discussion. And also, if there is an interpretation then of results or comparison with experiment, one can place it in this discussion section. So basically, anything that is not possible to characterize as introduction, methods, results, and conclusions goes into discussion. And I think we are not going to fill this form this time, but let me share what one can focus. So does discussion contain discussion? It's basically suggestions when giving little feedback to each other. So does discussion identify processes that are responsible for the main result? So result is explained, is an ideal explained in results, and then in discussion one can highlight what was the procedure. Here are some examples related to either one of our projects. Some correlations between conditions and how one can control to obtain or not obtain the main mechanism, the main result. And some of us mention it right in the results section, but the discussion section is the best place where to put this additional observations and correlations about computed data. The word about hypothesis was proven right or wrong in comparison to introduction is already done in the conclusions, but one can highlight it once again in the discussion section. And I apologize for repeating myself, just to attract the attention of the reader, to help reader to absorb take-home message. Sometimes one can make a little game and pretend that we do not know answer. We only hypothesize what it is in the introduction section. And then in the results section, one tells, oh, what a surprise, it does work, or the hypothesis was proved right. And if it is more than half sentence, then these exclamations could be relevant for discussion section. So I think I'm repeating myself between section 5 and 3. But if one observes any general trends that can be extrapolated out of this work to any work by people who will be your successors. So it also can be mentioned if appropriate in the discussion. Okay. I think I'm done with this little overview. Sorry if you hear it again and again from year to year. Maybe Amir and Aaron do not mind it. And I believe that the dark box on the right corresponds to mid. Hello,
Yes.
mid. Okay, yeah, nice.
I have a camera today, actually. I just
You do,
don't.
and you do have green background that helps you to change to put like you on a beach or in the vicinity of bridges and skyscrapers.
Yeah, I don't know how
Okay,
to do that with Zoom, but other places I have. So
chroma key. Yeah, nice seeing you. So let me suggest we go to the materials that we have. So the discussion sections from Amir, Mid, Aaron, and Yoon, and just give it a read through. So I believe I did enable it for writing, so feel free to type between lines, between words, or give a comment. And we should check back in today we have much shorter section than previous time, so it may take shorter than before. So maybe let's reconnect or talk to each other in like 40 minutes and try to go over the materials that we are looking through. Any suggestions or questions about the procedure?
Yeah, it says short and full for Aaron's ligands.
Yes.
Do you want us to read both then?
So Aaron did share the updated version of results, discussion, and figures. And figures take too much space, too much disk space. So the short includes only discussion and results, and full includes figures. So I would focus on short version only, but if there are some questions about content of the material, one can go into the full. But whatever you feel comfortable.
All right, thanks.
Okay. Yeah, and I thank you very much for reading materials of each other. It serves dual mission. On one hand, we are like if you are reading work of your colleague, you're helping to make it better. On other hand, you are observing strengths and weaknesses, and you make your own observation. Should I repeat the same passages or avoid doing them? So it's getting borrowing experience. So I suggest we just focus on the materials and read and give comments, and I will try to attract your attention in about 40, 50 minutes for discussing and making questions and answers section. Is it okay? Okay. Okay, let me attract your attention and maybe check if everyone is ready. If yes, we can go into the in discussing. Aaron, are you done with reading, or you need more? Okay.
Yeah, I'm done.
Okay. Yeah. Thank you. Yoon, are you done with reading? Okay. Thank you. What about Mead and Amir?
I'm here.
Did you finish reading of other pieces?
Yes.
Okay. Yeah. Thank you. Amir. Maybe Amir. You.
Oh,
Oh,
sorry, I'm here.
it's okay. Are you done with reading?
Yeah.
Yes. Okay. Yeah. Thank you. It looks like everyone is quicker than myself. Okay. Let's discuss the pieces as they are numbered. Maybe starting is the one written by Amir. So I did place several cosmetic suggestions, like the
May I ask a question about this part of discussion? Because Fatima add this first 2 or 3 lines to the discussion. I'm not sure about them. Dr. Killing, can you be more cautious?
no, the idea seems clear.
Okay.
I just pick the and pick about the words. So the band gap of an object, like as particle in the box, depends on the size. The bigger, if you compare different size objects made of the same chemical composition, then the larger the object, the lower the gap.
Okay.
And you may revise the particle in the box concept.
Okay. And for the first comment, you mentioned downward, but as Fatima wrote before, it's upward. So this makes me confused.
What?
The first line, she mentioned that the energy essays in the conduction band are
No,
normally shifted
so
upward.
you have two bands, conduction band and valence band.
Okay.
Tells conduction band goes up, and what about valence band? It stays the same or it goes downward?
Okay.
Let's check.
Okay, I will check that.
I'm not sure it's only an option, but maybe if the piece goes longer than one page, one can give subtitles for each paragraph. Sometimes it helps readers. So here you are telling that because of the band gap becomes smaller, the material becomes transparent. This, I'm not sure if it is sufficient, because like here the valence band, here conduction band, here the band gap. So if it goes to infrared and the rest of the bands are continuous, then the material will visually appear black as it will absorb in any range. So it should be additional condition telling that the levels are in the band are offset by substantial energy, or they do not have transition dipole. So just think if something can be added.
Okay, sure.
So Yvonne is asking how absorption is improved. What is lambda p?
You mean I need add the value of the lambda, or how we improve that value? So it's improved by a sampling.
It's two questions. First, maybe what is lambda p, and second, how the absorption is improved. It's to my understanding, Yvonne is not criticizing your results or your discussion. It's just suggestion to have additional disclaimer and definition.
Okay, sure. I will add them.
But can you answer right now?
Our target here was the lambda p reported by experimental data that was, for instance, around 800 nanometer.
No, definition. What is lambda p? Is it lower border of absorption? Is it like transition energy? Is it a gap in the units of nanometers? Like, what is lambda p? What is definition?
So it's the peak in the right side of the absorption spectrum.
Okay.
Is it right?
I don't know. You are the expert and the boss in this project. But the suggestion is that any symbol should be defined. And since we, maybe you will introduce it in the introduction, but which is a good style. But sometimes some readers do not read the whole paper. Maybe you can put reminder or just absorption peak lambda p, something like that. And what do you mean by improved?
Improve. So comparing to the results without sampling. So For instance, before sampling, the lambda is around, for instance, 1000 nanometer, but after sampling, it's
Okay,
very
okay.
close to the experimental value.
Better agreement with experiment.
Yeah, yes.
Yun, are you satisfied with these answers? Okay, thank you. So, the next sentence seems hard to understand based on Yun's comment. So I interpret that also it is not a criticism of your results or your wish to discuss the statement here. It's a request to be more logic, more definitions. Like,
Okay, I agree also with Dr. Han. I will improve that part. Maybe add more explanation or split that into 2 or 3 more sentences.
oh yes, yes, I'm very much for it. So the spin polarization keyword is not sufficient.
Yeah, you're right.
One can do spin polarization in singlet and get the same results as without spin polarization. So one needs the word triplet explicitly.
Okay, sure.
And Aaron makes suggestions to rank the importance of calculations. Like what is more important K points sampling, electron hole interaction, or interaction between electron and hole and electron between electron and nuclear contraction.
Okay, I will think about that and try to emphasize more these parts.
Would you like to ask Aaron to give verbal comment in more details, or
yeah, I wanted to ask, it's better to add them in the last of the discussion section or in the beginning? And Aaron, what's your opinion?
I mean, you could probably do both, like beginning and end. If like that's like your main finding of the paper that you want to communicate. I guess I think from reading your paper that like K-point sampling gives the best agreement with experiment. But I don't know. I found that you have to treat readers like children. You just have to tell them like exactly like the most important thing or exactly what you mean, or else their minds can, I don't know, drift.
Okay, yeah, I got your point. Okay, I will address Aaron comments. It's a very good suggestion to improve that section.
yeah. So I think we are done with discussing Amir's.
Thank you very much all for the comments, Dr. Han, Aaron, Dr. Kirin.
So let's go to the work by Mid. So Aaron is asking electronic structures associated with degradation. Mid, can you explain what it is?
I know DFT and the methods we're using it. You're calculating the electronic structures, and so I was trying to incorporate like a general way of saying we're using electronic structures, kind of, and using that information to analyze the degradation.
I believe you are not answering what Aaron is asking. Probably Aaron means definition of electronic structure of what? Of which molecular structures? So you can say electronic structure of different molecular structures obtained along the trajectory.
Oh, okay.
Just try to be specific because
Yeah.
same as in criminal movies. If police arrests someone, they give a disclaimer: any word you say can be used against you. So
Yep.
reviewers can use lack of definitions against us.
Mhm.
Aaron, did we with Meet address your question? Or you meant something different?
No, I think you got it. Yeah, what was unclear, it's missing an object. Usually it's an
Yeah.
electronic structure of
Okay.
something. So
Yep, I can put that.
Okay. Nuclear configurations obtain along degradation pathway. Would it sound better? Maybe Mead will do fine tuning.
Yeah.
Okay. Through, like I see 3 or 4 pieces across this discussion where you use wording highest amount of degradation.
Hmm.
It's quite clear for us inside the group, but picky reviewer may refuse to take it. Do you mean rate or quickest rate of degradation?
Yeah, I was assuming all videos kind of had the same endpoint, but they don't. So it would be highest rate. Yeah, definitely highest rate.
So it sounds like, it looks like you have several trajectories of the same rate. So not rate, same duration. And during the given time, one trajectory shows more decomposition, another less, which means decomposition occurs earlier at a shorter
Yep.
time.
Yep.
And the word rate would be more appropriate.
Yep. I agree.
Okay, thank you. So it's again. Oh, it's me. Okay. So something was not clear for me. Well, I pretend it's not clear. It looks like reason and consequence are inverted.
Okay. Fair enough.
Okay.
I skimmed over that.
Yun is asking for a summary that may help to interpret this sentence. So how many trajectories, how long, what's the duration of each trajectory, and what's the difference in excitation energy? Can you answer by word?
How many trajectories? Well, we're analyzing what, 2 of them, and then how long for each trajectory? Approximately 2,000 femtoseconds. And then how different is the excitation energy? I believe they're the same because we're inputting the same energy in both.
Okay. And Yun, is it what you wanted to hear? Okay. And Mid, I believe you did a huge number of calculations. So you studied like several dozen trajectories, and since it is already done, you may consider, just think inside yourself, would you like to brag about it and put something in the supporting information, or postpone it to a different paper, or say that we report most representative trajectories, something
Yep.
like that.
That is very reasonable. I can add that extra information in
Okay.
let's say supporting information or some sort of explanation in the discussion.
Energy absorbed by the water. It's not clear how the energy is transfer to the water. So highly likely it's due to collisions, but you may have different vision.
Well, my understanding is we're just inputting energy in the case of like the excitation, de-excitation process. And so I'm saying this excitation is occurring since we're inputting energy. So like the direct excitation is kind of what I was,
What's the band gap of water?
I don't know. I'm not sure.
Well, you may check it.
Yeah.
Reviewer may ask it. So and I suspect, or not suspect, I know for sure that the orbitals you involve are do not have charge density on water. So your optical
Okay.
excitation does not directly affect water molecules. So it's
Yep.
not direct optical excitation. Probably you activate some nuclear motion in the vicinity of the excited fragment, of the fragment that you perturb by excitation, and then through atomistic motion, it collides with nearby water molecules. So it transfers kinetic energy in the sequential process.
Thank you for explaining that. Thank you.
So you suggest that there could be a chance that there is an artifact of the mass spectrum. So if the species with hydrogen cross the boundary, and for a period of time, part of the molecule is at one side of the boundary, part of another, then there will be peaks with m over z equals 1.
Yeah, I'm trying to think because we used this particular mass spec is actually the 10-celled mass spec that we had
Yes,
generated, and
yes.
so I know that hydrogens can still cross the borders, but
But in a smaller fraction compared to one cell.
yeah,
Yeah.
yep. So I don't know if I need to explain further. Like, is it pretty common to just say, or is it pretty common for me not to be able to use this kind of concept about the large peaks in the hydrogens because of that? I guess.
It's better to make an attempt to explain everything.
Okay.
A reviewer will come after us.
Which is
Highlight.
okay.
If something is of secondary importance, it can be later moved to supporting information, but it's better to make an effort.
All right, I'll make an effort. Yes. Okay, I can do that.
Ewan, does our discussion address what you suggest?
Yes. And also for me, I never report this kind of values because first reason is this value is not very accurate compared to the other features. The second reason is this is not important information. The number of hydrogens does not matter at all.
Okay. Should MID skip the range from 0 to 5 m over z completely from the mass spectrum?
Yes.
Mid, would you agree to this suggestion?
Yeah, I can like actually omit that section even from the figure.
Yes.
Okay. Yes, I can do that.
Okay. Yeah. Thank you, Owen, for it will make life of Mid more sweet. Let's go further. So next comment by Yun that this verbal discussion of discoloration of opaque white fluid to transparent range seems odd because opaqueness is a consequence of scattering. So, do you have any possible plans to separate discussion of opaqueness and change of color?
Yeah, I can just simply get rid of opaque and transparent and just simply say white to orange.
Would it address your suggestion, or you have what is best way from your point of view?
I don't understand Mead's explanation. So you want to modify their observation?
We were replicating what we had seen experimentally, which is we saw before
But
excitation.
here,
Yeah.
but here you mentioned the liquid is opaque, right? Is this their observation?
So their observation was, yeah, a fluid that was opaque and had a white color to it, and then through excitation, turned into this orange transparent fluid. And so I guess I was focusing, we're trying to focus on the redshift. So if we only are looking at colors, it would make sense to omit opaque and transparent, and just focus on the white to the orange.
You just cannot do it, right? You
Okay,
cannot
why?
modify their
May
explanation.
I contribute a word? I'm not sure if I'm correct, but it should catalyze its understanding. So, as Yun correctly mentions, there is a process of scattering, which is not chemistry, or it's more physics. So when photon is not changing its frequency, but changes direction. And there is a one category, whether it is, whether the photons come through with some intensity, come through the material, or they scatter and go into different direction. So if there is a scattering and photons change direction, that even material with UV gap will look like whitish. If it is not a crystal, if it is a amorphous, then it will white, but the light doesn't come directly.
Mm-hmm.
So it's one characteristic. And another characteristics, what is the color and what is the band gap? So those are two features, and to avoid ambiguity, we should compare apples to apples. Like color and opaqueness, those are apples and oranges.
Yeah, okay.
Ewan, does it address your criticism? Okay. Yeah, Mead makes excellent observation that of correlation between where charge density is perturbed and the outcome of the fragmentation. Here, in the next sentence, it is not clear. It's clear since we know what the research is, but for someone who sees it for the first time, one may add a disclaimer that after the first fragmentation event, there is a sequence of other fragmentations event because the rate of reaction is so quick, and when we are past first step, there are further steps. Mead, does it make sense?
Yeah,
Okay.
I can add that.
Thank you. So Aaron offers a promotion, a suggestion of the mechanism, and asks if Mead agrees with that. So presence of water molecules creates additional interaction, electrostatic interaction between polar water molecules and the charge separated state, excited charge separated state on the polymer. Would you agree that this mechanism noticeably affects the outcome of the reaction?
Are you asking me or Aaron?
I'm asking you.
Yes,
I'm-
that is what I'm trying to describe. as of right, within the sentence, yes.
Aaron, did I interpret your question more or less correctly?
Mm-hmm. Yeah, the water just localizes the charge density. And then Mead mentioned a couple of other times that he noticed that localization promotes fragmentation.
Mhm.
So yeah, I was able to get that from your description.
Great. So next, recovery of original precursors is a very modern trend in the polymer science. So the keyword is upcycling instead of recycling. And it could be your paper can be sold at higher price if you pedal to the metal in this aspect.
Yep.
Okay. Again, I'm not sure, but maybe subtitles, chopping on the paragraphs and add subtitle may help reader. I'm not sure. I'm just asking. Higher peaks, taller peaks, higher intensity. Just double check for more for standard language.
Mhm.
If something sounds unclear, just chop on the sentences. Yuna is asking why to highlight bond length thresholds in different software if it is easily solvable.
Well, it's not necessarily solvable. Like, there's going to be some differentiation always, simply because, you know, the settings in one, even if I quote unquote use the best settings in JMOL, that still may not replicate exactly what OpenBabel is using. So that's why I kind of just put that disclaimer suggesting that there is a difference that may be attributed to this. So
I would put it less specific to the software, telling that interpretation or conversion of the trajectory into mass spectrum depends on definition of the bond threshold.
okay, rather than be specific, I can.
Let me type it quickly. Selection of influences trajectory into mass. And please fine tune to so it sounds better.
Yep.
Once I was delivering this method, TDSMD method, on conference in front of big experts, like author of the games software package. I have forgotten his name, but now he is in Iowa. Mark Gordon. So he's and his group were all asking, like, why do you guys use bond length as a criterion? Why don't you use amount of electronic density between each atom and order of the bond as a criterion for bond being broken or intact?
Mhm.
It's worth mentioning as an alternative, but I'm against using it because it is much more expensive in computing. So even if you get a little error, this method through bond length is much quicker. Aaron, can you explain your question?
I guess, like if this whole study wanted to be, like if you wanted to have a hypothesis stated like at first before doing all the simulations, like just from looking at the structure, is there any sort of like signs or chemical intuition that can be applied to where, like what sites are most likely to fragment first, and if that agrees with the simulations? It just helps make the paper into like a narrative that's easier to follow.
Yeah, I think it's a great suggestion. I
Hmm.
will definitely do that and put that. Would that be something more in the intro, or is the discussion the best place for that kind of
You
explanation?
Mid, you already mentioned it just in the through this abbreviations. But let me comment to Aaron, and then you both comment if you agree or disagree. So it is expected that this polymer that consists of furan and nitrobenzene group. Here are the abbreviations that I cannot read, FDCA. They are used to form a polymer originally. And the hypothesis is that bond between these monomer units is first to be broken upon photoexcitation. So the expected technological advance is that one can basically decompose polymer on monomers and then eventually recycle this solution of monomers for another event of polymerization. Because the old material has some strain, and after repolymerization, it will be like more mechanically stable or some benefits. Aaron, would you buy this? Did I lie in something, or generally it's right direction?
Explain it very well, Dr. Keller.
Okay, thank you, thank you. We are over time. We have 10 minutes for two papers. Let's go forward. I was reading the full version of Aaron's, and I don't know if anyone was giving comments to short version. No one gave to the short. Okay, let's go to the full. Really great formulation. No complaints. For bright traps states, I think it is something to highlight and emphasize. And if your results indeed support it, then one can make a buzz title like counterintuitive discovery that breaks expectations. Depart of the ligands, still keep the quantum dot bright. And there are some noticeable improvements in the figure. So I think this one that Yoon was criticizing in the past, so it partially shows some dissociation pathway. And this one, 3D, looks really great. It shows trends, and interesting that for distance and for angle, they're opposite. Cool. And there are several figures that show surface trap. Yeah, here is the full trajectory, also really great. And maybe if the brightness of the surface trap is main finding, that high, now you suggest to place this absorption spectrum in the supporting information, but if it will be the best result, maybe it can be moved back to the main. But you decide as you understand better the logical connection between units. Any verbal questions to Aaron? If no, let's go to the section by Yoon. So it is because the target of this paper is short style letter. There is an intermix of results and discussion, which is okay here, but for rest of us, please try to avoid it. So it's much easier to compose short out of long rather than opposite. So let's by now in general keep the longer paper style or components are fragmented. Reformation, I'm not sure if it is a standard word. Maybe it is, but so this maybe a little disclaimer of homoheterolytic. Aaron is checking if polarization is a sign of ionic bond. I have my version of answer, but maybe you can answer verbally. Or let me try first, and then you. So here, we through basic our educational background, we know that dihydrogen, molecular hydrogen, is like covalent. It's not ionic. But in the process of breaking molecular hydrogen onto pieces, there are alternative ways. Break it onto H plus and H minus on one hand, and break it on two neutral radicals. And Yulun is providing argument, numerical argument, that the polarization, which would be sign of H plus and H minus, is less possible, is probably not is going on. Yulun, is it what, did I answer the question of Aaron correctly, or you?
Yes.
Okay, thank you. Oh, never mind. Okay, good. So reformation of different oligomers of sulfur, maybe yes, maybe no, but one can consider to add a comment how frequent these components are observed in experiment or in nature. Because S8 is not the only part of nature of sulfur. Also, it looks like this paragraph is a new story, but if one reads not carefully, maybe I did miss something. One can highlight that it is a continuation of previously started story, or organized. So, like, we are refocusing on the same process, or we are going through a sequence of events, one by one. Does it make sense or not quite? Okay, thank you. So, as reading it, I keep worrying not about the great quality of the work, but about the expected results. So experimentally, one expects everything to convert into H2S, and here it does not. So maybe here and there, one can add a comment like, "Do not worry, more H2S will form if we continue reaction further." Just consider, because if H2S is not the major product, then it will be divergent from experiment. And if you tell that we are working on the intermediate steps, then it is okay. I'm just curious, what is H2S2? Is it what is the name? Is it similar to peroxide? And is it oxidizing agent? I will just look some online about it. So here it shows the list of products during this trajectory, but one can express hope that if one continues further, there will be a higher proportion of H2S. So we do not know, we didn't explore it, but hopefully. This one belongs to methods, but you consider later where to keep it, where to place it. So here probably you mean structural relaxation, right? Again, I'm coming with the same worry that eventually change of the proportion towards H2S as final product. One can even make a quick calculation without any computers or with online materials. Find total energy of 8 H2S molecules and compare them with any other fragments. I wonder if it will be much lower than anything else. At least we can discuss it between us to get more clarity. And in this short paper style, probably you do not add subtitles, but like one can add a comment that we practice the philosophy of synthesis and characterization approach, either in experiment or in computation. Okay, many thanks for everyone. It's a really great session. Please consider to implement changes in final version, and next time we will do methods, and in 2 weeks we will do introduction. Thank you very much. If needed, send me an email. We set up one-to-one meetings, but in less than 1 minute, I need to be in the other meeting and deliver a class. Okay.
Thank you very much.
Thank you.
Bye.
Have a great day.